So next is constraint optimization. A consumer and a producer are often constrained to meet their objectives. A consumer has limited income, which constrains him to buy combination of goods or some output to maximize his satisfaction. Cost may be a constraint to maximize profit of a producer. So a producer may have, say, cost constraint. Say suppose input prices are very high, he cannot afford. So how to maximize his profit? So it is a constraint. Let a consumer's utility function is U is equal to, U is the function of Q1 and Q2. Suppose two goods he will buy. So utility is the function of Q1 and Q2. And his budget constraint is Y naught is equal to P1 Q1. That means what income he has, it is exhausted in buying Q1 quantities at P1 price plus Q2 quantities at P2 price. Now using Lagrangian multiplier lambda, so P is equal to this function plus lambda times Y naught minus P1 Q1 minus P2 Q2. Now how to maximize P? So first derivative lambda V by lambda Q1 is equal to the first derivative with respect to Q1, because the function is not defined. So we'll have to write F1 minus lambda times P1 with respect to Q1 is minus P1 lambda P1. This is equal to 0. Similarly, with respect to Q2, delta V by delta Q2 is equal to F2 minus lambda P2 is equal to 0. Then lambda V, delta V by delta lambda is equal to, this is the coefficient of lambda, so Y naught minus P1 Q1 minus P2 Q2 is equal to 0. So let us mark it as equation 1, 2 and 3. Now first order condition is that F1 by F2 is equal to P1 by P2. That means, what is F1? It is the marginal utilities. Ratio of marginal utilities should be equal to price ratios. That is the first order condition. And from equation 1 and 2, we can get F1 is equal to lambda P1. So F1 minus lambda P1 is equal to 0. So F1 is equal to lambda P1. Then F2, similarly F2 is equal to lambda P2. Now if we divide equation 4 by equation 5, then F1 by F2 is equal to P1 by P2. So this ratio is the ratio of the first order condition. And level of Q1 and Q2 can be obtained from this equation. So if Q1 and Q2 are specified, that means the function is specified, then we can find out the level of Q1 and Q2. Now second order condition, the relevant bordered Hessian determinant be positive. Now substitute P1 is equal to F1 by lambda and P2 is equal to F2 by lambda from equation 1 and 2 and multiply through by lambda square, which is a positive. Then we get determinant of this F11, F12 minus P1. this is positive. So and to f1 2 times f12 f1 f2 minus f11 f2 square minus f22 f1 square is positive. So if it is positive, then it will be the case of maximum, and vice versa. Now n variable and multi-constraint. So there will be situations that there are n number of variables, not only 2 or 3, but n number of variables, and constraints are also more. Not only one constraint, but constraints are more. For example, for a producer, constraint may be capital, constraint may be labor. And for consumers, constraint may be income, and constraint may be other variables. So general notation is z is equal to, it is a function of x1, x2, so on up to xn, subject to constraint x1, x2, xn is equal to 5. Now Lagrange function, z is the function of this plus lambda phi minus, if we put transfer this to right side, so phi minus g x1, x2, so on up to xn. Now first order condition is that z lambda I, lambda 1, lambda 2, so on, should be put to 0, and z1 f1 minus lambda g1 is equal to 0, and z2 f2 minus lambda g2 is equal to 0, and so on. Zn is equal to fn minus lambda gn is equal to 0. So there will be zi equations. So when I is from 1 to n, n number of x, so there will be zi equations. Let us put to 0, and lambda I constraints to 0. Now if there are two constraints only, so put, say, z lambda is equal to 0, find out z lambda, put to 0, find out z mu, put to 0, and zi to 0. And these three set of equations should be solved for finding out xi, lambda, and m. So we will discuss some examples in the in our next discussions. So for today, thank you very much for watching, and please share. Thank you.